All right, good evening. Welcome back to College Algebra. And I guess we can start looking at some other topics that we have here. Okay, so let's see here. One of the things to talk about is, well, we did a lot of linear functions, a lot of linear models yesterday. And there's nothing wrong with, here's 2 points, figure out the equation of the line between them. It's always a very good skill to have. One of the other things that students often have problems with is function notation. Okay, so if we have something like an f of x is equal to 1 over something like x squared plus x plus 1, right? And I said, hey, I'd like to know like what f of 1 is. Okay, so this is the easy one. So we're going to do 1 squared plus 1 plus 1. So 1 squared will be 1, add 1 and 1, and we actually end up with a third. Okay, so not so bad. Now, what happens if I would like to figure out f of, say, a plus 2? All right, that's where it gets a little bit harder. How about we do plus 3? So this will be 1 over, right? Everywhere you see an x, you're going to put in an a plus 3. All right, you see how that works? And they're not going to be happy. Like, you can't just leave it like this. They want you to simplify it, so we have to keep going. Okay. So let's go ahead and do that. So a plus 3 squared. Right, that's a plus 3. A plus 3, and all we have to do, right, is we're going to FOIL this thing out. So we have our firsts, right? We have our outers, we have our inners, and we have our lasts. So we have a squared plus 6a plus 9. Okay, so here we're going to have a squared plus 6a plus 9. And then plus a plus 3 plus 1. And now we're going to combine our like terms. We're going to put together all of our a's. So we have 1 over a squared. We have 6a plus 1a is 7a. And then we have 9 plus 1 is 10. Okay. So that's what they want us to do with that. All right. Let's see. Let's try another one. Okay. Let's say f of x. I mean, that was a pretty tough one, but let's say f of x was equal to 3x minus 1 squared plus 10 x minus 1s, okay, plus 3. All right. And I would like to figure out, like, well, what is, say, f of c plus 10? Okay. So everywhere we see an x, we're going to replace it with c plus 10. So this is 3, okay, c plus 10 minus 1 squared plus 10, c plus 10 minus 1 plus 3. Okay, you'll notice I changed my brackets and my parentheses a little bit. Typically, your parentheses are like the inside thing, and brackets are one step out, and then these brace things are like the next step after that. Okay, so that's technically how that goes. Nobody will ever question you on that. Nobody will ever care. But the reason I did that in this case was I wanted to maintain the structure and say, okay, I've got something minus 1 squared. So here's something minus 1 squared plus 10, that same something. And I almost always like to put my substitutions in parentheses just because it helps me kind of remind myself like, oh, I substituted there. Okay. So do you have to do that? No. But I find it easier to keep track of what I've done in the middle of a problem. So here, right, there's no distributing, right? We have c plus 10 minus 1. Well, I could just write that as c plus 10 minus 1 squared plus 10, c plus 10 minus 1s plus 3. So there's nothing magic that's going on here. I don't have to distribute over it. This is just going to be c plus 9 squared. And there's 3 of them. Plus 10, c plus 9s plus 3. Okay, so be a little bit careful about that. I remember a couple of years ago, I think there was an algebra class I was teaching, and I would do this to them. Like, I used to just do quizzes. So I'd pick up 4 problems, and then every 2 weeks they would have to solve 4 problems, maybe 5. And I remember one algebra class had such a problem with this. I put something like this on every one of their quizzes. They always had trouble with it. So c squared plus, right? This is c plus 9 times c plus 9. Okay, so it's c squared plus 9c plus 9c plus 81. All right, so we have c squared plus 18c's plus 81 plus 10 c plus 9 plus 3. And the next question people ask, well, wait a minute, why didn't you distribute the 10? Because I'm not there yet. Okay, this step here, this line here was simply to expand out this polynomial. And the reason why I'm not going to keep going is because I kind of like to do one thing at a time, because if I try to mix and match and do multiple things, well, I still have to deal with another line because I have to do this one anyway. But the chances of me getting 10C and then moving on to something else without doing 90 is really high, and I'd like to make sure that I'm not going to do that. So I try to keep it to one thing at a time. We're going to distribute now. So we've got 3c squared. What is 18 times 3? Is 30 plus 18. That's going to be, no, 30 plus 24 is going to be 54. 54c. Okay, and then 81 is going to be 240 plus 3, 243. Okay. Plus 10c plus 90 plus 3. Okay, so we're going to combine terms, right? We're going to get all our c squareds together. Okay, that was it. We're going to get all of our c's together. So I've got 54 c's here. I got 10 c's over here. So that's going to be plus 64, right? 54 plus 10. Now going to be the hard spot, because we have 240 plus 90. So what is that? 333 plus 3. Okay. So that's our problem there. All right. So very good. Okay. So that's function notation. Sometimes they just give you two things to deal with, right? We have a 2, we'll do an f of x. We'll do a 2, x minus 4 squared. How about minus 3, x minus 4s plus 1. Okay, and they want to say, like, what is like x plus h? Okay, maybe I don't use x plus h. A lot of people were to hate that. Okay, until at the very end. But what if I do, x plus a? Right, that's horrible. Okay, so this is going to be 2. Right, we have x plus a minus 4 squared, right? No, let's go ahead and do it that way. Oops, this guy. Minus 3. I remember every c and x, we're going to replace it with x plus a. All right. So this one, like the other ones were nice because I had to combine terms. And as I was writing this out, I'm like, oh, I should have thought this example through a little bit more thoroughly. This is going to be awful. Okay, but let's see if we can do it. Okay, we can do this a number of different ways. How about we try this way? All right. So this is going to be x plus a times x plus a. So we have x plus a squared. I know we're going to need another line. Minus 4 x plus a's minus 4 x plus a's plus 16. Now this one, right, we're going to have to do this too. We're going to have x plus a times x plus a. All right. If you're doing this in your head, by the way, that's fine. I'm not, like if we were doing this in person and your next line here was x squared plus 2xa plus a squared, I would not question where that came from. And if you put it off to the side and did this, I'm not going to judge you. I'm going to say, oh, they must really want the right answer. Good for them. Okay, so here's our value. We put that in there. Okay, so we're going to have minus 4, right? You're $4 in debt, and you spend another $4. Now we're $8 in debt. X plus a's plus 16. Oh, there's a 2 out here, isn't there? All right, there's a 2 here. All right, so let's go ahead and see what we got. We're going to untangle this thing one thing at a time. This is a horrible problem. I'm looking at this like, who came up with this problem? Jerk. I haven't even gotten to the next part of this thing yet. Okay, we're here. All right. So remind me, don't put this problem anywhere that people would have to be graded for it, because this is the worst. Okay. So here we go. We have 2x squared plus 4xa plus 2a squared minus 16x minus 16a plus 32. And is there anything I can combine? Not a chance. Okay. So how awful. Okay. Now I'm just going to bring this part down, right? This is right. This is minus 3x minus 3a plus 12. I'm just going to bring that part down. So we have minus 3x minus 3a. What was it? Plus 12 plus 1. All right. Now I got some stuff to combine. All right. Sorry about this. All right. No, nobody gives you problems like this, by the way. I came up with this off the top of my head, and I regret it. Probably saying you regret it too at this point. Okay, we have a minus 16. Oh, minus 16 minus 3. So that's minus 19 x's. All right. Minus 16 minus 3. It's another minus 19 a's. Now we have 32 plus 1 is 33. Okay. Oh, how terrible. All right. That's enough of function notation. All right. Let's see. What else do we want to do? We want to do circles. I don't know if we want to do circles. I want to do transformations. Is always one that, I mean, connect makes this so much nicer. Yeah, but maybe we could look at transformations a little bit, because that's one that I always watch my students kind of. That's one where they have some problems. What am I doing? What is it? Transformation of the graph. I think we've done a lot of these, so I'm trying to find some that maybe we haven't done. All right. All right. you could do this, right? You can match the picture to the function, right? So let me go over, right, just a little bit. So we have three different families. Well, I put them into three different families, but we have linear, right? And we have linear is the constant function. We'll have f of x equals something. Here, there's y equals a, right? Does it pass the vertical line test? Yes. So that's why y equals a, it's a function. That's fine. And then we have the identity function. This is f of x equals x. I'm going to say pretend this goes to the origin because it's supposed to, right? This is just y equals x. And then you have linear. All right. These are all linear, right? Because here, right, the first one, the m is 0. Okay, we have no slope. We have 0 slope. Okay. Identity, well, m is 1 and b is 0. Okay. And in linear, we take gloves off and it can be whatever you want. Okay, I did say something. Let me go over that for just a moment. Occasionally, when we're dealing with lines, we're going to get something with no slope. That's x equals b or something. No, let me use a different letter. Okay, because b is the y-intercept. I just don't want to confuse with the multiple letters. Okay. Don't write down 0 slope here. Okay, so none is not the same as 0. Okay, I know that's a weird concept because English, if you say I've got none, then typically that also means you've got 0. But if you work at Bank of America, I'm going to apologize in advance. If you're a teller, this is not your fault. Okay, if you're an executive, then yes, I do mean to insult you. Okay, don't sue me though. Somewhere, like when you, I don't have an account with Bank of America. Okay, someday somebody's going to figure out that since I don't have an account, my account balance is 0. And since they have to maintain that account, they should be charging me a fee. And they could make it retroactive for, my whole life and charge me a fee for having a $0 account at Bank of America and then collect, a lot of maintenance fees from me. But that's ridiculous, right? Everybody would no, that doesn't work. But somebody could make the argument, well, it's none, so that means 0. And we maintain that account in good faith. You owe us a lot of money now. No. None is not 0. Okay, these are different things. So in math, 0 and none mean two different things. In English, not so much. But in math, none is not the same as 0. All right, so be careful about that. Next family is the polynomial family. All right, polynomials, the only two we have to know, right? Y equals x squared, something like that. And y equals x cubed. Okay, this has the advantage, pretend x goes to the origin. This does have the advantage that this is also x to the 4th and x to the 6th and x to the 8th. And this is also x to the 5th, x to the 7th, x to the 9th. So they all kind of have the same shape here. All right. So we have linear family, that's these three. This is not a function, so this doesn't count. So we have linear function, and then we have polynomial function, or polynomial family. Then we have the radical family. Right, we have y is equal to the square root of x, and y is equal to the cube root of x. This is also x to the 1/2, that's what square root means. And this is x to the 1/3, that's what cube root means. Okay, and what these look like, It starts at the origin, grows. Cube root goes through the origin. Something like that. Okay, y equals the cube root of x. Y equals the square root of x, right? So these are the radical family, okay? And the other nice thing about this is, like, if I said, well, it's x to the 1/5, it's got effectively the same shape. X to the 1/7, it's got pretty much the same shape. X to the 1/4, it's got the same shape as x to the 1/2. Okay, square root of x, technically fourth root of x is going to look a lot like this. Okay, but we only care about those two for now. Okay, and then we have the rest, other. Okay, we have reciprocal. All right, and we have absolute value. So those are the general families of functions that you have to know. It really does help to memorize those. We kind of assume that you will know what these look like without having to do too much work. Okay. For now, like, if you're still running them and you want to type in, make a t-table and plot some points and see what the shape looks like, then go right ahead. But generally, we expect you to kind of have an idea of what these things are looking like. So when they come out with something like this, right, from memory, match the equation of the graph, right, y equals x squared, you're supposed to know that's what it looks like. All right, I don't really want it. It's a lot just to ask me one question. All right. Again, sketch the graph from its memory, absolute value. There we go. All right. So they're going to, I don't know if they're going to ask you that on exam. I don't know if I asked you that on exam. But, it goes to the whatever's going to happen next, because we're going to use translate. Like, if this was face to face, I would not give you the y equals x here, right? We wouldn't have a function. I would just say graph it, or I might say graph the parent function. That's the absolute value, and then graph the transformation. So all we're going to do, right? This is on the outside. This is a vertical shift because it's away from the function. It's away from the parentheses, and it's negative, so we're going to go down too. All right, and that's what that looks like. Okay. Same thing with this one, right? We have a rational function. We have a vertical shift of 5. So you're just going to pick up this graph. You're going to say, okay, I'd like to move it. And we're just going to move the whole thing. 1, 2, 3, 4, 5. Okay, and then you're set. Okay, hopefully I counted to 5 correctly. There are days. There are a lot of days. All right. Inside, it's a horizontal function. Okay. Now, the weird thing about horizontal functions is they kind of work backwards from the way you think they ought to, right? This is y equals, or f of x equals x minus 2. X minus 2 means we're moving to the right 2 spaces, right? If it were x plus 2, we would move to the left 2 spaces. All right, so be careful about that. If it helps you, I'm not going to be looking over your shoulder to know what you did or you didn't do. If it helps you to plug in and, like, okay, what if x is equal to -2? Well, then -2 plus 2. Okay, that's the 0 point. Okay, what if x equals -3? Well, then we have -3 plus 2, absolute values. Right? Absolute value -1, that's going to be 1. Okay, so I'm not going to know that that's what you did. And if you got to do that for a couple of problems, then I say so be it, right? I mean, it'd be nice if you got to the point where you could look at this and say, oh, horizontal shift to the right, no problem, right? But, it doesn't have to be that way. What happened with this? Calc 2, what am I doing with this? All right, so we're going to move this thing 2 points, okay? And I guess we're going to check. Okay. Oh, scary. Okay, cube root, all they want us to do is move it though, right? All they want us to do is move it. And what's that +3? It's on the inside, okay, which means it's a horizontal shift. Okay, and it's a plus. Normally you'd think, oh, plus that goes to the right. I'm like, no, in this case, plus goes to the left because it's horizontal. Okay, so m of x is equal to the cube root of x plus 3. We're moving 3, right, in the plus direction and to the left. So we're going to really, okay, so we're going to say this is 3 units. Excuse me. And all we're going to do is take this point here. 1, 2, 3. And that's all we do. Okay. I should stop saying it that way. A lot of students have a lot of problems with this particular topic. Okay, I should not trivialize it. Because if you're stuck on this, you're like, well, I just don't quite get it. You are not alone. Okay, there are a lot of students that have a very tough time with this. All right. So 1 over, and if you're not having a tough time, you're like, yeah, it is as easy as you think it is. Like, count yourself lucky, count your blessings, and move on. All right. So here, right, we have 2 things going on. We have a horizontal shift. We have a vertical shift. Generally, you want to take care of the horizontal stuff first. It's inside of parentheses, really. So we have a 2, right? We have 2 to the right. We have 2 raised to the left power to the left side here. Okay, so whatever we have here, right, 1 over x, we're going to move it. We're going to move it 2 points this way. So it's going to be out here. Same with this one. All right. It's a terrible drawing. Sorry about that. Oops. There we go. Right. And then once we're done with that too, then we're going to move everything here. We're going to move everybody down 3 steps. Okay. And that's how we're going to handle this. Okay, so generally you want to work from the inside out. Okay, sometimes it doesn't matter, but generally you want to work from the inside out. So we're going to take our tool here to pick up and move. We've got 1, 2. All right. And then we're going to keep our tool here. We're going to move down. Okay. 1, 2, 3. All right. And that is how we're going to handle that transformation. Find some better ones here. Okay. Y is equal to 1/6 x. Okay. The 1/6, it's multiplying. So it's not a vertical shift. It's not a horizontal shift because we're multiplying. Okay, that's a different kind of shift. All right. What's going to happen is it's kind of like somebody sat on this graph, okay, and compressed it because it's 1 over 6. If it was a positive 6, then that would be somebody would take this graph and they would kind of, I don't have enough room to do 6, but they would stretch it all the way out. Okay. So a compression here, it's like somebody sitting on it, but if it's going to be bigger than 1, right, then we're going to be stretching it out. Okay. So here we go. We have y is equal to f of x, and f of x is equal to 1/6 x. Okay. So instead of being up here at 6, right, if I'm going to multiply this by 1/6, what's going to happen here with the zeros, right? If f of x is 0, then multiplying it by 1/6 is going to do what exactly? Not a thing. So the only thing I have to worry about here is what's going on with this point here, okay? So we're going to do a 1 right across the axis, -6 and +6. So it's still going to be down here and up here. and then down over here. That looks pretty straightforward for a change. Usually when we have to graph these things, it never goes well. Okay, so that's an improvement. Okay, but that outside thing, that's a vertical stretch or a compression, depending on if the number is bigger than 1 or smaller than 1. Okay. Here. All right, nice one. This is oh, I like this one. Okay, I've used this one before. All right, so what's going to happen with this y equals negative x? Well, it's going to flip it. Okay, it's going to flip it. And is it going to flip it above and below? That would be the outside one, right? This is an inside x. So it's going to flip around the y-axis. So we're going to flip here. Okay, oh my goodness, how much nicer is this than what we used to have to deal with? It's 1. Hello, what are we doing? Oh, okay, I guess I don't see the whole thing. All right. Now this one, right? We have this circle here, y equals f of x. We have that half circle, and then this is y is equal to negative. What's going on here? Remember what the negative does, right? It flips it, but it flips it in a vertical fashion, not a horizontal fashion like we just did. So we're going to flip it. All right, and that's how we do that. Oh, this is terrible. Okay. Let's see here. There's a lot going on here. Okay. I occasionally throw stuff like this at my students for in class, but because we don't have the nice easy tools for Connect, I generally don't put a problem like this together because it's just too much, right? After a certain point, it's like, okay, I'm just going to plot some points and see how it goes. Okay. All right. So what do we have here? Graphing in the following order, right? We want to do horizontal translation, stuff inside the parentheses. Okay. Horizontal and vertical stretch. Again, this is times. Okay. Reflections, also times. And then vertical translation is a shift. Okay, vertical shift. So on the outside, it's the last thing you get to do. Okay. So what do we do here? Okay, so here, right, we've got a horizontal translation. We've got 8.3 to the right. So the parent function, that's just x squared. How do you know it's x squared? What other parent function would fit? Something times x minus blah squared and then a vertical shift tacked onto the end. Because it looks like a squared, I'm going to go with the basic function is x squared. Okay. And I don't know if I don't know if they're going to let us graph it, but if they do, okay, you'll see. It looks a lot like x squared. It's just weird. It's just different. It's not placed in the same spot. Okay, but the basic shape is going to be the same. All right. So let's see here. Basic function, x squared. And then what do they want us to do? Okay. They want us to shift. Right? What's the negative, right? We're going to shift to the right. We're going to shift graph of f to the right, 8.3 units. Okay, double checking to make sure. Okay, 8.3 units. Okay, then what do they say to do? Okay, they said apply horizontal or vertical translation. So we're going to put a 1/8 here, right? So we're going to shrink, compress. I always like to say compress because to me, the visual of somebody sitting on the graph is, it works really well. So we're going to shrink the graph vertically by a factor of 1/8. Okay. And then what do we have left? Then we're going to shift. We're going to look for the y, right? We're going to look upwards or downwards. And is it upwards or downwards? It looks like it's up, right? It's positive. So we're going to flip upwards by 9.3 units. And hopefully none of this makes a liar out of me. So there we have some transformation. That was a tough one. Okay. But I do really like the fact that technology kind of aids like what we have to do. You're not counted on, like you get to do this on your own. And I pull the questions, right? We pull the test questions out of the Connect Math, so you have practice with the kinds of things they're going to ask you in the format they're going to ask you. Okay. So it's not coming out of left field, like, where did this ever come from? Like, chances are you had a chance to practice a lot of these. Okay. They have a whole pretest. You should look at it. Okay. Again, transformations to deal with this function. So we've got a 2, right? That's going off to the right. We got a 3. That's not a compression this time, right? That's we're stretching it. And then we have this 3 at the end. Vertical translation, right? Minus 3 points. Going to go 3 down. Okay. Kind of looks like a x squared, or not x squared. Kind of looks like a square root. All right. Oh, we don't have to do that this time. Okay. Well, we're going to move 2 units to the right. Okay. Now we're going to stretch this thing. How are we stretching? Okay. Well, whatever we have here, right? We're multiplying it by 3. All right. And then we're going to go back here and we're going to hit it with minus 3. So we're going to go 1, 2, 3. All right. And there we have it. All right. By the way, this is about as hard as I ever make it. Like, I don't. If I go with 2 things, that's fine. But this has 1, 2, 3, 4 pieces to it, and quite frankly, this is like the hardest one, the hardest type I would get. There's a lot going on with this problem, right? But we're going to go right. We're going to go 3 to the left or right, right? 3 to the left. 1, 2, 3. We're going to multiply it by a -2. So we're going to, instead of this point here, right? I'm looking at -2, 1. And if I was going to bring this up, right, then I'm going to go with 1, 2 units here. Right? And then I'm going to say, well, we need to, right, we need to deal with that negative. So I've dealt with the 3, I've dealt with the 2, I've dealt with the negative, just the way they said in the previous problem. And then we're going to get -4. All right, and that's going to be it. Oh, it didn't like that. What did I do? Let's see, we moved 3 over. We did. Oh, did I not? Can I reset? Is that what this does? How do we do that? Okay, there it goes. So let's reset it. So 1, 2, 3. Vertical stretch of 2. That's probably where I messed up, by the way. There we go. Just that one. All right, I'll bet that's where it was. Okay. And then we're going to go ahead and flip it. No. Flip it. Okay. And then we're going to subtract 4. 1, 2, 4. Check this one. Okay, there we go. It's a lot better. Okay. This is really the best I could do for you with function transformations. Okay, this is what we have. Okay, and it's not right to make it the hardest problem you've ever seen. All right, that's not good. But you just want to get like a representative example here. So x minus 1, that's going to be movement horizontal to the 1 to the right. All right. And we have a shift, we have a stretch of 3, factor of 3. So we're going to hit that. Notice we're at 2, 1, right? If I'm going to multiply this by 3, then I'm going to be up here. 1, 2, 3. All right. And then finally, we're going to subtract 2. We're just going to move this whole graph down. 1, 2. All right. And there we go. Oh, know what's going on over here, but all right, that looks terrible. Okay. All right. So that's function transformations. Let me see what else we have to cover here. Let me look at this. Oh, I don't want to go back and restart this thing because I think I'm going to give away grades or something. Log me out. Okay. But we had circles, we had distance, we had midpoint. Okay, so let's see here. We had circles. We have distance. Midpoint. Okay, we have a function notation. We have linear. Linear functions, linear models. This is just like y equals mx plus b. You get numbers without a context. The models is you get them with a context. Okay. And then so then they'll ask you like what the meaning of the slope is, and it'll actually be an answer. If I just give you 2 points, I say, what's the meaning of the slope? Like you don't have anything. You've got rise over run. It's like, okay, if I really wanted you to tell me that, but here you're going to have things like wind speed over barometric pressure or miles per hour, right? Something you made into a fraction. Okay, and then we have graph transformations. I'll do my best to see if I can find another thing to deal with here, but I think I can call it here. Okay, so I'm going to stop recording here, and we'll figure out what we're doing tomorrow.